In these problems, we're working with systems of equations, and we're going to use a method for solving them called elimination. And this is a pretty handy, easy way to solve systems, especially if the equations lend themselves to it. Let me show you how it works. What you basically want to do is line up your equations so that all the x terms are in one column, y terms are in one column, the number terms in another column. And we're going to add these things together, and hopefully we're going to get one of the variables to just disappear. The trick to make that work is that you can multiply one of these equations by something. In this case, we want to solve for y. So what I'd like to do is get rid of the x term. So I'm going to take this bottom equation and multiply the whole thing, both sides, by -3. Now I'm allowed to do that. Rules of algebra say as long as I do it to both sides, it amounts to the same thing. So my top equation stays the same, 6x minus 4y equals -1. My bottom equation, let's multiply the -3 through. -3 times 2x is -6x. Now you can see what will happen here when we add them together. The x terms will come out to 0. It'll disappear. So that's good. But let's finish our multiplying through. -3 times a -5y, that's a positive 15y. And a -3 times a -2 is a positive 6. Now we're just going to add down the columns. So this comes out to 0x, 6x plus -6x. So I'm not even going to write that. X's just disappear. -4y plus 15y, that would be 11y. And -1 plus 6 would be 5. Now to solve for y, I simply divide by 11 here, and we get y equals 5/11. So I've solved that system for y. If I wanted to completely solve the system, I could take that y value, plug it back in to one of these equations and solve for x. But this time we only had to solve for y. All right, let's look at a slightly trickier one here. It's got some fractions, but that won't slow us down. One thing to notice here, they want us to solve the whole system, so we're going to find x and y. One thing I notice right off is that I've got y terms that are basically the same, -y/3 and -y/3. If I simply make one of these a positive y/3, when I add them together, boom, the y's will disappear. So I think that's the route I'm going to take. So on the bottom equation, I think I'll just multiply everything by -1. If I do that, it basically just changes the sign of everything. So this would be a -3x/2. This would be a positive y/3, and this would be a positive 17/6. Now I can go ahead and add down, and when I do, the y terms will disappear, which is exactly what I want. I've got a few other hitches here because I've got some fractions that don't have the same denominators. So I think on my x terms I'm going to convert this one to fourths down here. That would be multiplying the top and the bottom by 2. That would be 6x/4. And over here I think I want to convert them both to twelfths. This one's in twelfths. This one I have to multiply by 2/2. So that's going to be 34 twelfths. All right, now I can do my addition. So x/4 and a -6x/4 is going to be a -5x/4. The y terms disappear, and 11 twelfths plus 34 twelfths is going to be 45 twelfths. Now, I think what I'm going to do is convert this guy to twelfths. So that would be 15x, -15x/12. I just multiplied by 3/3. Once I've got the same denominator on the bottom, I can just get rid of it. What I'm really doing is multiplying both sides of the equation by 12 and getting -15x equals 45. I divide by -15, and I get x equals -3. I'm not done though. I have to solve the whole system. I found x. I need to plug it back in and find y. So I think I'll take this top equation right here and set that up. So let me give myself a little more room here. So instead of x, I'm going to put in -3/4 minus y/3 equals 11 twelfths. At this point, I think I want to convert everything to twelfths. This would be times 3/3, so that would be -9 twelfths. This would be times 4/4, so 4y twelfths. And once I've done that, I can multiply everything by 12 and get rid of the denominators. So I get -9 minus 4y equals 11. So let's see, I'll add 9 to both sides, and I would get -4y equals 20. Then divide both sides by -4, and I get y equals -5. So my solution here for this system would be -3, -5. And that's a little bit of work with solving systems of equations by elimination.